Hello everyone. In this video, I'm going to be going over how to solve different types of quadratic equations, namely with the square root property, factoring, completing the square, also known as CTS, quadratic formula, and I'll briefly mention some TI-84 graphing calculator techniques that can be used as well. So first, when does each of these strategies work best? The square root property is going to work best when there is no b term, when we can clearly, or easily I should say, get something squared isolated, whether that be a binomial like x plus 3 squared, we can get that by itself, whether it just be x squared that we can get by itself. That lack of an x term is going to allow us to take square roots of both sides. Factoring is probably the easiest strategy on this list, other than maybe if something is really easily solved with the graphing calculator. Factoring strategies like GCF, a equal to 1, a greater than 1, can all be used to solve a factoring strategy using the zero product property, and we'll talk about that. Completing the square, probably the least popular, least common technique. It's going to work best when a is equal to 1. And obviously completing the square is very algorithm-like, very step-by-step, procedural, if you will. So we'll go over all those steps. Quadratic formula is going to be your universal tool, something that will always work, but might take the most amount of time. So if there is an easier strategy, you want to probably rely on that first. And then obviously the graphing calculator for multiple choice questions, checking things over, maybe giving you a little bit of a, leading you in the right direction if you're really unsure what to do at all. All right, so what I figured we'll do here, we'll kind of look at an example. We'll talk about the process of how it can be solved, and then ultimately we'll solve it. So for number 1, we have x minus 3 squared, quantity there, minus 2 equals 23. So what I'm going to do first, change the color here. I'm going to move this 2 over. And what we should notice, what a lot of people do with problems like this is that they'll immediately jump into like box method. Like, oh, I see something squared. Let me kind of box method. Let me multiply that out. And what you're really doing is making the problem more difficult. By moving the 2 over, we can clearly see here what I mentioned earlier with the square root property. Let me just unzoom a little bit so we can see all the strategies. With this property, we just have something squared by itself. So now I can take the square root of either side. If you box method that out, you're going to have to end up doing like completing the square or quadratic formula or some other strategy. Let's say this one wasn't factorable. You're going to have to do one of those, and then it's only going to lead to more work. You were like a few steps away from the finish line, and you made it more difficult. Okay, when we take the square root, we're undoing or canceling that square. We get what's in the radicand, what's underneath the radical. Be careful on the right. When we take the square root of a number, we have both positive and negative solutions to consider, plus or minus 5. So this is going to have a rational answer. And what this tells you is this was factorable if you did get it in standard form. But oftentimes with square root property, with completing the square, with quad formula, your solutions are irrational. This one just happened to work out nicely. What I'm going to do now is add 3. And I like to kind of sandwich the plus and minus symbol in the middle. It looks a little weird otherwise. And you don't want to leave your answer like that. You want to actually write down the 2 solutions you get. So one solution would be 3 plus 5, or 8. And the other solution would be 3 minus 5, or negative 2. And those are our answers. Very, very important. If you ever solve a quadratic and you get rational answers, that means the original problem was factorable. Not saying that we did something wrong here. Given what we were, what we started with, this was the best technique, but just keep that in the back of your mind. If you get like a whole number, an integer answer, a rational answer, I should say, the original problem was factorable if we got it in standard form. So that's the square root property for example 1. For example 2, 6x squared minus 5x. So right away, I see the minus 5x here. I can't use square root property in any capacity. I don't want to just like get the 6x squared by itself and hit it with the square root. That's not going to do me any good, because then I'm going to have an x trapped under a radical that can't break free. So square root property is out. Completing the square, I don't really want to mess with here, because again, completing the square only works best, or it works best when a is equal to 1. Can you do it when a is not 1? Sure, but then you have to divide it out. and we're creating fractions, and it makes the problem a lot more difficult. You really want to take the time to see if a problem is factorable. This one doesn't look like it right away, but it's worth the 20, 30 seconds of analyzing it rather than jumping into quad formula. So those are our two avenues right now. We could do quad formula and just kind of forget it, or we can kind of study it for a moment and see if it can factor. So for factoring, this would be an a greater than 1 strategy. With some textbooks, some teachers call an AC method. For my classes, I call this an eyeglass method. Basically, you're taking into consideration the fact that there's a number in front of x squared. And I call it eyeglass because it makes a little pair of glasses like that. And we're looking for two numbers that have a sum. Again, we're still pretending, not pretending, but we don't even know if this is factorable. We're looking for two numbers that have a sum of -5 and a product of 6 times -21 is going to be -126. Whenever we have a negative product, we know if this does end up working, we know it's going to be a positive number and a negative number. That's the only way to get a negative product here. Now for 126, kind of a difficult product, so you can grab your graphing calculator. What we can do is go to y equals. We're going to type in -126 divided by x. And we're going to utilize the table. Hit second graph to go to our table to find some choices that can work out here. Just by scanning up and down in my table, if you could see that, if it's coming out very well, it reminds me of some of the factor pairs. 126 isn't necessarily something that we know the factor pairs of anyway. And I clearly see here, I get -14 and +9. So this does work. This does factor. Like I said, I think I said 30 seconds earlier, like a minute or so. Now factoring is going to be a lot easier than jumping into quad formula. And we know this is also going to have rational answers. So quad formula would have been a waste with the radical and things like that because it would have simplified anyway. Okay, so now we're going to rewrite the expression. We're going to throw in a 9x and a -14x to re-represent the -5x that was originally there. We're going to factor by grouping. Everyone explains this a little differently, does this a little differently. I like to add these little brackets. For factoring by grouping, we're going to pull out the GCF. So 3x times 2x plus 3. And over here, be careful, the lead coefficient was -14. We're going to factor out a -7. If your lead coefficient is negative, you have to pull out that negative. That's an important concept with that second bubble, let's call it, second binomial. Now we have a common bubble of 2x plus 3 we can factor out. We're basically factoring out a binomial. We are factoring out a binomial. And I call these the leftovers. What's left over when you pull out a 2x plus 3? You're left with 3x minus 7. Okay, remember this is all set equal to 0. Sometimes with quadratics, if it's not set equal to 0, you have to do that. All right, now we're going to utilize the zero product property. We make our t-chart. We're going to set each bubble equal to 0. And we're going to solve these little, I call them mini equations, because they're simple, they're short, they're 1 or 2 step equations, but I see a lot of errors here, so make sure you're not making a mistake. We get 7/3 for one solution. Leave it as an improper. And over here, when I divide by 2, I'm going to get x equals -3/2. Okay, a little sloppy towards the end there, so I'm just going to write it a little bit cleaner. We get 2 solutions of -3/2 and 7/3. And again, improper is fine as long as it's simplified. And that's it for example 2. So factoring paid off there. Okay, for example 3, just to save some time, we would get it set equal to 0. We could check for factoring. Example 3 is not going to factor. It looks like it because you get -16, you see an 8 there, but there's nothing where it quite works out. So this is going to be our CTS example, our completing the square example. I have an a equal to 1, which is nice. Okay. So what I do for CTS is I move the constant away. And I'm actually going to give myself some space here, and I'll show you why in a moment. With CTS, you have this idea of like you want to throw this number into the problem. You want to add something to both sides. Both sides because you want this, it is an equation, you want it to be balanced. That number that you add to both sides isn't random. the number that you're going to add to both sides is going to be half of b, in this case b is 8, half of b squared. Half of b squared. So if we think of b being 8 in this problem, half of that would be 4, squared would be 16. If you get a little confused with that idea, don't worry about the sign of b because you're squaring it anyway. Some people make a mistake with, like, let's say it was negative 8x. It's always going to be positive, the number you're adding, so don't let that confuse you. And the reason why this works, after we do this process, this is then a perfect trinomial, something that can be factored as x plus 4 times x plus 4, or more simply, x plus 4 squared. Okay? You can sit there and do your sum product rule for factoring, or you can just use this idea that this will always be half. This will always be half. Okay, now let's go back to example 1. When we have something squared isolated, hit it with the square root. We're going to get the radicand, x plus 4. Now, unlike number 1, 32 is not perfect. So I still want to put a plus or minus. And I like to do this right away. Some people will save it till the end. Let's simplify the radical here. So for radical 32, let's think about what perfect squares go into 32. 4 goes in. I want to search for the largest, which would be 16. So 16 times 2, radical 16 times radical 2, is going to become 4 radical 2. Plus minus, whenever you take the square root, positive and negative solutions to consider. Now, once again, the last step here, I like to sandwich the plus and minus in the middle. And this one, you can't do any sum. It's just going to be this. We can't add a rational and irrational number together. We're just going to leave it like that. If you did have, like in example 1, when we had 5, we actually were able to add these together, right? We split up. We said, all right, 3 plus 5, 3 minus 5. In this one, there was nothing to add, so just leave it like that. All right, and our last example. This one is a little messy, so what we're going to do is get it in standard form. We haven't really talked about that. Standard form means ax squared plus bx plus c equals 0. So everything on one side kind of in a correct order, equal to 0. So I'm going to move everything to the left. I get 3x squared minus 4x and minus 2. If ever possible, I try to keep a positive. So you might be saying, why didn't you move the 5x squared to the right? I just like to keep a positive, if possible, for factoring reasons and things like that. Okay. So let's try the one technique we haven't done here, quad formula. So quadratic formula, we're going to use x equals negative b plus or minus square root of b squared minus 4ac all over 2a. What I like to do is identify what a, b, and c all are before just kind of plugging into this aimlessly. 3, negative 4, taking into consideration your signs, and negative 2. Now let's plug in. Negative 4 is going to become positive 4. All over 2a, 2 times 3 is 6. I'm kind of cleaning up as I plug in. Negative 4 squared, be careful, is 16, not negative 16. Minus 4 times a times c. Okay, let's clean up the radicand, the stuff underneath the radical. We get 4 plus or minus. We had, let's see, 4 times 3 times 2 is going to give us 24. 16 minus negative 24 is 16 plus 24, or radical 40. Okay, so we got that. And what I like to recommend, if you're a little uneasy with the arithmetic, type what's underneath the radical into your graphing calculator just to get that number 40. You don't want to make a mistake with like a negative sign or subtracting all of that and mess that up. Okay. Number one mistake people make with quad formula is this. They'll make like 4, 6 into 2/3 and they're like, that's it. So we can't do that. One, because that'd be breaking our order of operations. We just divided before we took care of, there's really like an imaginary parentheses up here, right? Because it is in the numerator. So what I want to do first is simplify the radical if possible. And 40 can be broken down into 4 times 10, which works out nicely to 2 rad 10. So we got something going. And I call this with my classes, I say make a little heart to remind you, some people say a triangle, that all 3 of these numbers, a little broken there in the bottom, all 3 of these numbers have to have something in common. and they do here, which is a 2. So I'm going to divide them all by 2. I'm just going to put a 1. We're not going to put that in our final answer, just to show you what I'm doing. So all 3 of those numbers, the 4, the 2, and the 6, have to have something in common. This way, when you're dividing out the GCF, you're not breaking any order of operations rules. And now my final answer is going to be 2 plus or minus. You don't have to write a coefficient of 1. So we're just radical 10 all over 3. That's our solution for example 4. So the only example that I'm not going to actually do a problem for, I'll just show you some screenshots, the graphing calculator. So these are 2 things you can do on your calculator. Again, this would work best for multiple choice problems, a problem where maybe you did it like the first time and now you're just checking your answer. So one thing you can do is type the equation into y equals. Now for this, obviously it does have to be cleaned up a little bit. Like if you were doing the previous example we just did together, you would have to have everything on one side, kind of in standard form. Type it into y equals, and you can utilize what's called the 0 function, the 0 feature on your calculator. That can be found by hitting second trace, and then it's option 2 for 0. Now, it's a little confusing for some people because it asks them left bound and right bound. And it depends on the, root that you're looking for. What your calculator is basically doing is kind of like zeroing in on, literally, like, all right, where's the left side of this root and where's the right side of this root? So it depends on which one you're looking for. If you notice on the right-hand side, this is left bound. The function is left over here, and this is right bound. But for this one, they kind of switch. So it can be a little tricky if you've never done it before, but it's a nice feature. The other thing you'll notice is you get a decimal. Your calculator is not going to say like 2 plus or minus radical 3 there. So what you would then have to do is just verify, like, hey, if you did have an irrational answer, just make sure that that decimal matches by using the home screen features in your calculator. The other thing you can do here, this is a little bit more obvious, but for nice answers, type the function into y equals, go to your table, and just verify your zeros that way. Now, the downside for this would just be if you're using your normal table, you're only going to see integers on there. Now, you can adjust your table by hitting second window and either turning it on auto or changing what the table goes by. You have that little, you just get the right symbol here, delta table, or you can turn independent on ask, and this way you can type in any x value. But for most people, their standard table is just going to be integers. Okay. So that was a lot on quadratic equations, but hopefully I covered a little bit of everything on how you can solve them, applications, how you can analyze them, and hopefully you found this video helpful. Thank you all for watching. Have a great day.